Greetings. Welcome to my session at VMworld 2019 through the vBrownBag Tech Talk series. I want to thank the team here for having me on board, but I'm going to get right into the session here on intelligent validation of autonomous systems and sensors. This is part one. I plan on having the follow-on to this series as part of the vBrownBag series itself. Give you a little background on myself. I've been in the past working at VMware for 12 years, 3 years at EMC, and most recently at VirtuStream. I'm now working on a new startup that is tied to some of the stuff that I'm going to be discussing today. I'll let you read this, no problem. Agenda is let's cover what I mean about autonomous systems and sensors. What are some of the challenges that are faced in this? If you think of IoT systems, how do you validate all the sensors working together? I have a challenge from the automotive industry related to this topic area with some examples of what's happening today versus what will happen tomorrow once you start adding some of the new emerging technologies around deep learning, computer vision, and also big data. So first off, autonomous systems are in many different industries. The ones that I'm focusing on are in the automotive space, but there are also other areas that this can be extended to for intelligent buildings, intelligent marine devices, airplanes, you name it. The thing that I want to show here, though, as an example, is from the automotive industry and talk about some of the things that we see as far as the edge cases and some of the use cases. In this particular slide, I'm showing you some of the examples of things that have to be validated in an autonomous vehicle. Things around the roads, detecting when there's divided highways, there's lane changes, locations, there's speed limit signs, and so on. And the idea here is to be able to provide drivers with alerts for cross traffic, for blind spots that you need to be warned against. If you're about to depart the lane that you're in, give you a nudge on the steering wheel or provide a sensor in the car to give you a warning. And for fully autonomous, getting to the point where it can do corrective action to prevent a disaster. So I'm going to show you a fairly complex slide that shows you what it looks like in an autonomous vehicle. Later on, I'll talk a little bit more about the connection with cloud and with virtualization, but let's focus first on what does the system look like. So first, we have an overall compute system or a compute environment to support processing of all this data that is coming in from the number of sensors. We have secondarily cameras that are used for things like lane departure, identifying objects in the road, and also visual odometry. Third area is on radar for multiple different sensing situations. It could be used for intelligent parking assistance or automated parking, as well as object detection. And finally, the third area, which is very important, is with LiDAR, laser interface, for actually scanning an environment to see what is out there that could potentially cause a problem or trigger an edge case within the autonomous system. So let's talk about the challenge. And again, in this case, I'm talking specifically around the automotive industry, and in many cases, it's driver-assisted technologies as well as semi-autonomous systems. When we look at a level 1 system, we call this basically assisted driving. This is where the driver still drives the car, they still make a lot of the decisions in there. Things that might be available at this level include cruise control, adaptive cruise control. If there's cars in front of you, there may be a back off to slow down to make sure you're not going to have a collision and so on. The second level is where we start getting into the automation, where we start driving to semi-autonomous and fully autonomous vehicles. This is what's considered partial automation or feed off. The car can handle the brakes, the gas, and so on, but you may still need to be able to manage the steering of the vehicle. When we get to conditional automation, this is considered hands-off. Things like driver monitoring, things like automatic emergency braking, and some of the other things that I described at the lower levels. These first three levels are essential as the foundation for fully autonomous vehicles. When we get to level 4, this is where we get to high automation. We call this eyes off, meaning yes, you could sleep in your car while the car is driving, but there may be some need initially for some awareness to awake the driver or let the driver know that they need to take some sort of action. But in this case, it's less and less driver action. Pretty much you see here, hands off, feet off, eyes off. But the final stage is full automation, which we consider mind off, meaning no steering wheel, no gas or brake pedals or clutches, things like that. But instead, you might have an emergency power off button in case you're aware that there's some imminent situation where you need the car to just shut off, stop, and avoid a potential situation that the autonomous sensing technologies cannot cover. So when we look at automotive safety and effectiveness, one of the things that I thought is when some of these sensors, some of the warning systems became available, that they were in the 80 or 90% success rate. Let's take a look at what the International Institute or Insurance Institute of Highway Safety says, and this is from August. There's an update from just a few months ago that you can look at online. Forward collision, lane departure, blind spot, and cross traffic are all less than 30% successful in the majority of the cars that are out there from the primary manufacturers. Part of this is there is so much data that is collected, and I'll talk a little bit more about that. Because there's so much being collected and there's a lot of manual processes, this can take a long time. And to that point, doing data ingestion may take a certain number of days to go through and do some drives, collect some data on the sensors, and store that data. Then we get to analytics. We start looking at all that data and seeing, was there an issue? Did a sensor not trigger to warn the driver? Did some proactive action like emergency braking not happen because maybe we used one sensor that didn't identify a problem? And we get to the final stage where there's visualization. How do you represent this information so that a car company can take a look at the environment and say, we should make a correction, choose a different sensor, choose different placements. One example is stereo cameras. If they're in the same device and you only have 2 inches separation, that does not work the same as having one camera on the left side of the car and one on the right side of the car. These are all things that can benefit from doing a full analysis of the data on what is working, what is not working. So how do we improve things with emerging technology? There are 3 key areas that I'm working on that I see as being valued. One, there's big data. Cars are generating huge amounts of data on the order of 4 terabytes per hour in some cases. Some it may be over per day. Regardless, it's still a lot of data. There are hundreds of cars that are doing testing. And if you have a technology like OnStar in your car, there is data like this that's already being collected that can be used for analysis and specific analytical routines to help improve the vehicle and improve driver safety. Computer vision helps, as I said before, on lane departure. You need those visuals to understand what does the driver see, not just what the camera sees. So you use cross-correlation with the other sensors that I mentioned, LiDAR, radar, GPS, and other technologies like that. And the final stage is on deep learning. Why do we want to keep petabytes or exabytes of data? It's because deep learning takes advantage of having all that data to find things that a human just can't do because of time and because of the quantity of data that's out there. To do things in hours versus months requires things like deep automation for the analytics. So let's think about tomorrow. Let's say we apply big data technologies. We apply deep learning and computer vision. Well, we get to a point where we can reduce the time of manually doing all of this and only looking at a small set of data from months down to hours, where we cover 100% of the data, we increase the detection rate, and we reduce the time to completion. So now I want to give the cross-correlation, and I mentioned this, I think, in some of my tweets. There is a play with cloud, there's a play with virtualization, and there are a number of technologies that can help in this space. I'm still early on, and because I'm at a stealth company right now, I can't go into all of the details, but I'll give you an indication of some of the things you can look at. First off, the hardware layer. Your traditional compute environment technologies exist, but now we start adding on accelerators, video processing units, graphics processing units, tensor processing units, even FPGAs that are customized for certain evaluations of the sensor systems. On top of that, we can choose to place our environment for doing this validation on a virtual infrastructure or in the cloud environment. In my case, with the stuff that I'm working on, we're trying to focus on a SaaS solution so it can be any cloud, anywhere, and if the data from a particular customer is with one cloud provider, we can then provide support, moving the compute technology to where they have their data versus trying to move the data to where we have our compute. So the idea is have hybrid and multi-cloud considerations in support of that. And the last area are 3 things that I mentioned plus one more. Deep learning, computer vision, big data, these are part of the analytics. But what I see going forward in IoT or systems and sensors that are used for safety in many different industries, secure ledger is one of the technologies that can help make sure that you have a chain of control and evidence of every person or every technology that has touched this to make sure the data you get at the final end to store for the analytics is not corrupted, it's not tainted, it's not having some false information injected into that space. Because one of the things that is very important is regulatory compliance. And there are more things that are happening, not just in the US, but around the world in different countries that are focused on this. And you have to think about traditional car companies versus the companies that are focused specifically on full automation. Lucid is one car company. Tesla, everyone is pretty much aware of. There's a few others. There's a few trucking companies as well. I think this can be extended, the technologies in this space on using these technologies to support analytics around the validation can apply to aerospace, to marine, to energy, and a number of other industries that use these types of sensors. I think of this as an IoT problem, whether or not the industry calls it an IoT problem, especially with 5G. 5G is going to become a very essential part of having these smart systems, smart cities, smart transportation technologies working together. So in the tail end here, I wanted to cover two key things. One, lessons learned. What are some of the things that I've learned up to this point, working for the last few months with this new startup, but also the last few years around working at Dell EMC and VirtualStream on platforms for AI as a service or IoT as a service. First, data storage. Do you choose big data or traditional? Second, data privacy concerns. Think about looking at visuals of cars that a camera might catch on the road. Well, if you capture a license plate and you can tell what the car is and you know what the location is, you can be in violation of GDPR and other types of regulations. In the US, we're not actively right now in many companies focused on GDPR, but everyone here recognizes that we want to follow the guidelines of all the different compliance areas to make sure that we don't get locked out of particular market spaces, and GDPR is one of those big areas. Last two, compute technologies. It's more than just CPU. There's these accelerators like GPUs and TPUs, and the last one is there's another benefit to municipalities, to people who manage the road systems, the environment that's for transportation, to actually understand where are some potholes, is there a missing sign, is there a problem with signage, are there particular other issues, is there construction going on? These are things that can help shape the intelligence within a car to basically have a safer environment going forward. Last thing I wanted to cover is a number of things that you can see related to what I'm talking about. Most of the things I'm calling out here are tied to IoT. The technologies that are being covered with Pulse IoT and some of the supporting areas are definitely applicable to what I'm doing in my space. But there was an announcement, I believe it was on Monday or Tuesday in the keynote, on the Horizon 5G environment. That really is key to what we're trying to do as we go forward in many of the companies that are trying to do IoT or doing things where there is a lot of data being collected real time that has to be processed either at the edge or uploaded at the core. So I want to thank everyone here for joining, and for those that are out on the boards who are watching online. This again is part one of a multi-part series. Watch on the vBrownBag site for more information. And again, thank you to VMworld and also to the vBrownBag and Tech Talks team for pulling off another great conference. Thank you guys.